to Chemistry 12, Chapter 5, Lesson 4, Amines. Objectives. By the end of this lesson, students should be able to classify amides, define amides, prepare amides, name amides, and write some chemical reaction of amides. First, types of amides. We have three classes of amides. The first one, it is unsubstituted amide. Unsubstituted amide, we have RCONH2 or C double bond ONH2. If you replace one hydrogen atom, you will get monosubstituted amide. So if you replace one hydrogen atom by alkyl or aryl group, so you will get the monosubstituted amide. If you replace two hydrogen atoms by two alkyl groups or aryl group, so we will get disubstituted amide. So we have three classes of amides: unsubstituted amide, monosubstituted amide, and disubstituted amide. So you have to focus on this functional group. It is for the amides. Now, what are the amides? Amides are derivatives of carboxylic acid or acid anhydrides, okay, by reacting with ammonia or with amines. Now, this is the carboxylic acid, and this is the primary amine. If you take OH from the carboxylic acid and H from the amine, we will get the monosubstituted amide. So this is C double bond O or CO, C double bond O NH. So this is the functional group of amide. You can write it C double bond O NH or CO NH. Now, preparing or preparations of amides. From carboxylic acids and their derivatives with ammonia producing unsubstituted amide. If you have, this is carboxylic acid or acid chloride or acid anhydride. So any type of them with ammonia, all of them, they give us unsubstituted amide, the same formula. The difference only the side product. If we have carboxylic acid, we have to remove OH from the acid and N from the ammonia, remove them as H2O. What remains here? Two hydrogen atoms. You have to put them instead of OH. If we have acid chloride, instead of OH, you have to replace Cl. So Cl is removed with hydrogen atom. We have HCl as a side product. What remains here? Two hydrogen atoms instead of Cl, so the same compound. RCOO with H from the ammonia, we have RCOOH. What remains here? It is RCO. This RCO, and here we have NH2, so this is RCONH2. So if you want unsubstituted amide, so you have to react ammonia with acid, carboxylic acids or acid chloride or acid anhydride. With the primary amines, if the carboxylic acid or acid chloride or acid anhydride react with the primary amine, so in this case we have monosubstituted amide. How the reaction takes place in this case? You have to remove this Cl with one hydrogen atom. They go as HCl. Now, what remains here? It is RCO. So this is RCO. Then you have to join NHR. So this is NHR. So this is monosubstituted amide. With secondary amines producing disubstituted amide, you have to take carboxylic acid, acid chloride, or acid anhydride. In this case, the same rule, you have to remove this Cl with one hydrogen atom. They go as HCl as a side product. What remains here? We have NRR. 'R'. 'R'. So you have to join with the N, 'R', 'R'. So this is 'R', 'R'. So this is monosubstituted amide. 'R', 'R'. So this is monosubstituted amide. 'R', 'R'. So this is NRR. So you have to join with the N in this nitrogen atom. Now what we have here, RCO, so this is RCO, NRR. So this is RCO, NRR. So this is for the reaction of secondary amines with carboxylic acids or acid derivatives. Now what about the tertiary amines? Amides can't be prepared from the tertiary amines. Why? Because in the tertiary amine there is no hydrogen atom attached to the nitrogen atom. Now examples. Instead of the R you have to write CH3COH, so this is acetic acid. Acetic acid with ammonia, just you have to replace this OH by NH2 here. We have to OH, remove with H, so it is H2O, and you have to join NH2 with CO, so we have CH3CO NH2, so it is acetamide. Here we have CH3COCl. As I said, you have to remove this Cl with one hydrogen, and here we have NH2, they replace Cl, so CH3CO NH2, the same compound, just the side product is different. Here we have CH3COCl. This is also primary amine, here with ammonia. This is with the primary amine. Just remove one hydrogen from the primary amine with Cl and join the rest from the same position that you cut. I cut from CH3CO from here, from CO. So you have to join with NH, then go back to C6H5. So NHC6H5, the same position. Here we have another example with, acetic anhydride. With acetic anhydride, you have to take this one, CH3COO with hydrogen atom. So CH3COOH. H it is from here, from the end. Then join the rest. The rest from the compound, here we have CH3CO, CH3CO, and the rest from this compound is NHC2H5. Now, naming of amines. In the name of amines, we have two types of the name. The first one, it is the common name. The name of amides as the name of the carboxylic acid, the same. Just replace ic acid or wick acid in the acids by the word amide. Examples. Here we have CH3C double bond O NH2. It was CH3C double bond OOH as acid. But if it replaced by NH2, it becomes, amide. In the acid, we call it acetic acid. So remove ic acid and replace it by amide. So the name gets acetamide. Acid, it comes from the acetic acid. Then remove ic acid and replace it by amide. If we have OH here, it is benzoic acid. Remove wick acid and replace it by amide, so it is benzamide. It was benzoic acid, so now replace wick acid from the acid and replace it by amide, so this one we call it benzamide. Here we have the same rule. We have to follow the same rule. So this name, here we have the nitrogen atom. Okay, it is like the benzamide, but you have to focus here. We have the nitrogen atom. So in this case, we call it nicotinamide. Here we have, this is the two carbon atoms. We call it acid. And here we have the aniline. This is from the amines. If we combine them together, we get the acetanilide. So it is acetamide and aniline. We call them acetanilide. Here we have the famous name for this compound, C double bond O NH2 NH2, you can write it CONH2 by 2 because this NH2 NH2 by 2. So this example or the famous name is the urea. Now, what about the IUPAC names? We call it International Union of Pure and Applied Chemistry. We have the rule. Here we have to write the alkane and remove the E and write the suffix, it's amide. So it is alkan amide. If you have any substitution on the nitrogen atom, so write the N or assign it with N, then add the name of the carbon. How many carbon do we have? It is alk, then add YL and the name of the amide, the same alkane amide. Examples for this one? Look, here we have CH3, C double bond O, and H2. So this is unsubstituted amide. How many carbon do we have? We have 2 carbon atoms. What is the 2 carbon atom? It is F. Then we have to write ethane amide. So it is ethane amide. If we have 3 carbon atom, here we have it is propane. But if you have to remove E from the alkane, from the propane, and then write amide, so it is propan amide. Here we have, if you have branches, so CO and H2 takes the lowest number. So this C, number 1, here number 1, number 2, number 3, number 4. So this one CONH2, it takes the lowest number. You have to number from this side. And here we have a branch at carbon number 3. What is this branch? It is methyl group. So at carbon number 3, we have 3 methyl. And the longest chain here, it is butan amide. Here we have another example. Look, here we have monosubstituted amide. In this case, this one CH3 attached to the nitrogen atom, so you have to write it N-methyl. Methyl because you have 1 carbon atom and attached to the nitrogen atom. So it's N-methyl, and the longest chain here, it is propan amide. Here we have 2 CH3. We have di CH3, as branches on the nitrogen atom. So it is di-substituted amide here. So in this case, we write it at nitrogen atom, and also at nitrogen atom, we have dimethyl for this compound. What is this compound? C4H9. So it means it is CH3, CH2, 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 CH2. Then we have CO. So how many carbon atoms now we have? We have 5 carbon atoms. So 5 carbon atoms, we call it pentan amide. Here, what is the name for this compound? You have to guess this compound. Yes, this is N. This is CH3, CH3, and this is the amide. Yes, so this is how many carbon atom? 2. So it is ethane, and here we have N-methyl, and this is another N-methyl. So what you call it? NN dimethyl ethane amide. Here we have benzyl ring and C double bond O in H2. You can write C double bond O as CO. Then we have NH2. Or this benzyl ring, it can be written as C6H5. Then we have CO and H2. So what is the name now? These compounds are the same. So what is the name? Yes, it is benzamide. Now what about this compound? Look, we have a branch on the nitrogen atom. It is methyl. We have another branch. It is ethyl. So how many carbon atoms do we have? 1, 2, 3, 4. So what we call this compound? What is the name? Yes, it is N-ethyl. So this is N-ethyl, and N-methyl, and also we have another branch, this is methyl. For the longest chain, there are 4 carbon atoms, it is butanamide. Again, you have to focus on the alphabet, ethyl before methyl. Now, what about this compound? CH3C double bond O, NH, and this is the benzyl ring. We have here, we have 2 names, maybe common name, maybe the ionic name. Here we call them acetanilide because this is from the acetic acid or acetamide. Then we have, this is from aniline, so it is acetanilide. Or you can say, this one as a branch on the nitrogen atom, if you have the benzyl ring as a branch, we call it phenyl. Then we have 2 carbon atoms, we call them ethanamide. Now, these are the naming of what? Of amides. Now we go to the next point, this is the reaction of amides. In the reaction of amides, we have many types of reaction. The first one, we call it reduction reaction, or we call it Hofmann degradation. In the Hofmann degradation, it means the reduction of unsubstituted amide by sodium hypobromide to produce the primary amines. Here we have benzamide. Okay, in the benzamide, just you have to remove C double bond O. Okay, you have to remove it. So this is benzamide. If this C double bond is removed, you get the aniline, and aniline, it is the type of amines. We have another example, CH3C double bond O NH2. Here we call it acetamide by hypobromide, maybe sodium hypobromide or potassium hypobromide. We write only hypobromide. So in this case, you have to remove C double bond O and write the rest of the compound. So here we have CH3NH2, CH3NH2. You have to focus on or notice that this amine decreases by 1 carbon atom from the amide. Here we have 2 carbon atoms, but here we have only 1 carbon atom because this C double bond O is removed. The second reaction, we call it the hydrolysis of amides. We have 2 types of hydrolysis. In the first one, in acidic medium, they give carboxylic acid and ammonium salts are formed. Here we have the compound acetanilide. So if you have He2O, and this is the point for this is H+, it means any proton from any acid. Maybe it's HCl or HSO4, any acidic medium. We write it as H. Okay, what does it mean hydrolysis? It means to break down this compound in the presence of hydrogen and water. The bond between C double bond O and NH, so you have to break this bond and add OH to C double bond O and 2 hydrogen to NH. Again, these 2 hydrogen, put them with NH, so they become NH3+. And here we have CH3C double bond O. You have to write OH. So this is CH3C double bond O, OH. This is in the acidic medium, so it gives us the ammonium salt. This one we call it anilinium ion. And this is what? This is the acid. So it gives us carboxylic acids and ammonium salt. In the basic medium, salts of acids and amines or ammonia are formed. The same thing, here we have NaOH. So this is in the basic medium. The same reaction, you have to break this bond between NH and C double bond O. We have only 1 hydrogen atom. You have to add it to NH. So in this case, we get NH2 as aniline, it is amine. Here we have CH3C double bond O, and here we have NaO. I cut from this between O and H, so you have to join from the O. Here we have CH3 C double bond O, O Na. So CH3 C double bond O, O Na. So this is sodium acetate as a salt of acid. And this is amine, but we call it here, it is aniline. Now the third reaction, it is by the dehydrations of amides. And this is very important reaction. Okay, removing, it means eliminating or removing water molecule from the unsubstituted amide gives the nitrile. This reaction takes place by the phosphorus pentaoxide B2O5. Look about this reaction. Here we have the unsubstituted amide RC double bond O NHH or NH2. Before this reaction, we have as equilibrium between these two states. This is unstable state. One hydrogen atom from the nitrogen atom goes to the oxygen, and this bond is put it here. Now we will get this figure. This process we call it as a tautomer, and here it is unstable. It is easy to remove H2O. Now we have triple bond. Now this is 1, 2, 3 bonds, so this is RC triple bond N. This one we call it nitrile. And here it is the action of amide, but it is preparing of nitrile. Example, if you have acetamide or ethanamide, CH3C double bond O NH2, we don't need to to write this step, just you have to know it. Just remove H2O. This is H2 with O, so we have 1, 2, 3 bonds, so here it is acetonitrile. So this is about the reactions of amides. The last topic, it was about the nitriles. Nitriles are C triple bond N. They are derivatives of amides, as I explained before, by eliminating or removing water molecule by phosphorus pentaoxide. So it is the same, it is reaction of amide and the preparing of nitrile. So the same reaction, RC double bond ONH2, remove 2 hydrogen atom and oxygen atom, you will get nitrile. The same example, CH3C double bond ONH, this one you call it acetamide or ethanamide. Remove H2O, you will get the acetonitrile, or you can write ethanitrile. Thank you very much.